All right. So if you have not labeled your notes, please do so. Today we're looking at absolute value inequalities. All right. Before we get too far into it, though, I'm going to have you try a problem from, this would have been from last Friday. Because if you recall, last Friday, we did what were called compound inequalities. And we did not have homework in the sense of you solving them as much as we were working out on that Google form on Friday. So everything involving today will fall into one of the two categories, somehow an absolute value with a less than, or it could be a less than or equal to, and then a greater than or a greater than or equal to. So before we get into that, though, I would like you to try this one here. Your answer should match one of those four. While you're looking at that, I'm going to give you your quizzes back. If we have time at the end, we can talk about your quiz, or you can set up a time to come see me, probably during advisory, if you want to do that, to take a look at your quiz. Okay, so you try that. Should match one of those four answers. If you recall, if you go back and look at your notes from Friday, you're going to see that you should be boxing your information here. If you go back and look at it, box your information. As you're getting your quiz back, first of all, don't be in as big of a panic as I think some of you are initially going to be when you see the amount of red on top of your paper. Unfortunately, in some of these situations, if you make a mistake somewhere near the top, it's going to trickle down through the entire problem. So it's going to look a lot worse than what it really is. Okay, so it's me just trying to show you where your mistake is going down through the problem. Now, I did, even if you got it right, put a check mark next to each one. That's for me, just trying to keep straight of what's what on your paper. So at this point, though, you should have this statement boxed and rewritten two different ways. You should have a statement there. -5 is less than or equal to x minus 1. That should be one of the statements on your paper. And then you should have a second statement written on your paper that says x minus 1 is less than or equal to 2. And there should be a word in between those two right there. Yes, ma'am? What's the word? It's got to be an and. Okay. These two inequalities are written together. And so therefore, this is an example of an and compound inequality. Solving these should not be anything crazy. They're both little one-step problems. You're just simply moving what in each of them? You're moving, move the -1. Okay. Because the variable was the piece that was encapsulated in both sides of this problem, it's essentially going to look like I did the same thing to both of them. So I'm going to move the 1, and I'm going to get -4 is less than or equal to x, or essentially x is greater than or equal to -4. So that would be at -4 going which way? Going to the right. And then if I add the 1 in the second one, that would say that x is less than or equal to 3. So that's closed circle at 3 going to the left. So which one of those graphs does that? It is B. All right. Choice B is an and statement. It's got two n values and those results coming together in the middle. Okay. That also includes the -4 and the +3. If A would have been the right choice, what type of compound inequality are you looking at there? It's an or. There's two statements that are going away from each other. What about D? What would D be? It's tiny, but it's still and because they're coming together. What about C? Jack? Good. It's just a single inequality. It just simply says that x is greater than or equal to 3. It's just 1. Okay? But compounds have to be more than 1. In fact, they're 2. Okay? We're going to need this idea today. So this is our stuff from Friday. We are trying to do 2 things: to graph and solve an absolute value inequality. And really, if you wanted to, this probably should also have a less than or equal to, and then this one should also have a greater than or equal to, because either they're both the same. The only thing differently graphically between those is what? Good. Whether the circle's open or closed. That's it. All right. In order to be able to do this, though, I need you to think back to solving an absolute value equation. So if I gave you one, here would be an example. If you had something like 2x minus 4, the absolute value of that is equal to 10. Any takers? That's all the way back. We looked it up earlier today. It's in chapter 2. You still have notes from chapter 2? Could you find chapter 2, section 5? Like, you should be able to. You should be able to just flip back until you found a heading that said chapter 2, section 5. That's not an unrealistic expectation. What's up? Oh, you have the answer? What you got? X equals 7. Okay. What am I waiting for? Sticking with 7. What's up? You don't agree with 7?
I didn't really check that. I was thinking X equals
3.
I didn't label any of chapter. Wait, no.
No.
Yeah, it's 7.
7. And negative 3.
Is it the one concept?
There are 2 solutions. Can you find something in your notes that looks like that? Where it's been split into 2 halves. Who said they couldn't find chapter 2 in their notes? Who was that just said that a second ago?
I didn't realize that we were supposed to be taking notes.
Oh. Like for real. All right. Yeah. Why do we take notes? Because you said I had to? Because you keep saying take out your notebook? What chapter? Chapter 5, section 5. Well, you just asked me the chapter, so I told you the chapter. Now you're going to roll your eyes at me. Mm-hmm. So this is section 5-5. This is absolute value inequalities. What's up? Well, that would be one hope, right? That we actually reference them at some point. And some of you will, and some of you won't. All right. And your other hope is what? Well, it's kind of a way, yeah. Right. We always talk about we can't study for math. We don't know how to study for math. Well, you study by practicing, right? And so in order to practice, you got to actually write. And if you just sit there and give me the old head nod as we're going along, that's just code for you ain't doing squat, right? I mean, that's really, give me a couple along the way, right? So you gotta actually be like an active participant, and to do that, you're probably going to have to take notes along the way. Now, one of the hardest things I think for you guys is understanding what should your notes look like. Like, how do you actually take notes? That's got to be a skill that you kind of develop along the way. And that's trial and error. You might be like, nope, wrote too much, can't get all that done. He left me behind, and I was still in the middle of trying to. So you got to streamline yourself a little bit, but at the same time, you got to figure out what's important. Now, as soon as you guys saw me put this T on here, a lot of you, yeah, 2 solutions, right? But we don't remember that piece on our own, and that's fun. We gotta try. Now, Kyler, you told me you thought that your answer originally to this was 7, and I agree with you, because if I take the 2x minus 4 and I set it equal to 10, I'll add the 4, I'll divide by 2, and I'll get an answer of 7, right? That is definitely a solution to this problem. What's up? And now, do you have a second equation written? What did you write? Okay, why do I set the exact same expression now equal to the negative? I can't hear you. That's true. I'll learn how to count. Don't worry. Thanks. All right, got it. What's up? Um, that's all right. Okay, what do you think? Oh, um, me too. Yeah. Okay. What did you write, if I may ask? Yeah, and a lot of people have tried to do that. We're trying to flip this value inside. Remember, you're trying to take this expression that's inside of here, and because there's an absolute value, what's up? Okay. So we've got to look at this same 2x minus 4 both here and here in two different ways because this thing could be equal to a positive 10, which would still be 10, or it could be a negative 10, which in the absolute value would still be 10. And so we end up with a second possibility over here. Jack, I think you gave it to us. What did you give me? Negative 3? Because that negative 2 or 2 times negative 3, that's negative 6, and minus 4 more, that's negative 10, right? If I graph that, what would it look like? How would you graph x is equal to 7 and x is equal to negative 3? Put a dot on each of them, right? That's it. But if these equations had inequality symbols on them, what would you do with them then? You'd add lines, and maybe those lines would go together. That would be what type of compound inequality? If the lines came together, it'd be an and. But if those two solutions had signs that went away from each other, then that would be an or. And so imagine that today what we're really looking at is that if this symbol right here is not an equals, but it's a greater than or a less than or a greater than or equal to or less than or equal to, I'm going to set it up the same way. I'm going to set it up with two different possibilities. However, this time, they're not going to be equation answers. They're going to be inequalities. And those inequalities may produce two results that come together, an and statement, or they may produce two things that go away from each other, an or statement. All right? So that's what we're looking at today. We're looking at 5 total questions. 6. I lied. I don't know how to count. You clearly saw that a second ago.
Before we continue, this was 2 what? So I can label it.
2 5. Okay. Yeah, it's written over there. Okay. I know. I could tell. That's why you yelled, right? Okay. So here's your first problem. Now, these are all pretty simple. So you probably could look at this right now and tell me you know the answer. Yeah, you could. Tell me the value S. What could it be? Give me some value of S that if I take away 3 and take the absolute value of it, it'll be less than or equal to 12. Give me something. 15, that'd work. Oh, that was all your answers? What are the chances? I mean, 15 minus 3 is 12. The absolute value of 12 is 12. And negative 9? Negative 9 minus 3 is negative 12. The absolute value of negative 12 is still equal to 12. Okay, we got 2 answers so far. Are there more? Oh, come on. Give me something else. Stop for a second. Just think. Could you give me something other than 15 and negative 9? Does 0 work? Oh, yeah. What's 0 minus 3? And the absolute value of negative 3 is 3. Is 3 less than or equal to 12? I'm back on the horse. That's 3 answers so far. Give me something else. Okay, I don't know about that one. What's 21 minus 3? 18? Absolute value of 18 is 18. 18 is not less than or equal to 12. So I got 15, negative 9, and 0. Got those 3 so far.
5.
Anything less than 15? Anything less than 15? Like a negative 100? Really? Oh, Logan says anything less than 15 and greater than negative 9. Ah, you see how this is kind of starting to play together. In this situation, we found originally the end caps. We found the 15 and we found the -9. We knew those were the two ends, but actually, all the things in between them also work as well. That's why 0 worked, or 1, or 2, or 3, or anything up to 15. Okay? So, thinking about this in a graphical context, if I started here at, oh, let's get a better pen than that. There's 0. If this was 3, 6, 9, I literally can't count today. 9, 12, 15, and 18. Oh, this is gonna look weird on my. Yeah, why don't you do that? And then on this side, -3, -6, -9, -12. All right. We just said values from 15 all the way down to -9, and we think all the things in between them are going to work. We think. That's what it sounds like, right? But I want you to think about this problem exactly the same way we thought about an equation. I want you to think about splitting your paper into 2 halves. Now, we don't need to literally split our entire paper, right? But wherever we're working this problem, maybe that little piece. What statement am I going to write over here? Hey, you think you know what it is? Beautiful. Now, this one, though, might catch us for a little bit of a loop. Ah, you're close. What do you think? You would. So what am I going to actually write over here? S minus 3. Good. Greater than or equal to -12. So in an equation, I was just changing that value, but in an inequality, I actually will need to take that sign and change it as well. Now, these are simple little one-steppers to solve, right? If I add 3 here, I get less than or equal to 15, right? And if I add this one over here, I get S is greater than or equal to -9, right? And it should be, right? So I'm actually going to take these little lines off here and replace them with closed circles, because those closed circles indicate that I'm talking about being somewhere at -9 up to a positive 15. Okay. Now you're sitting there going, oh my goodness, how in the world did all that just happen? Or how did I just get all that to take place? Well, I'll be honest with you. It started right here. That symbol actually told me that this was going to happen. Because I wanted to be less than a value, on one side of things, I kind of gave a top cap, which ended up being that 15. And when I flipped it and I looked at it from the negative version, it actually gave me the bottom cap. And it produced all the values in between. This will always be the case when the symbol is a less than or a less than or equal to. Okay? These types of statements, erase a little box right there. And we're going to write something in there. What am I going to write? And. That symbol is always going to produce an and statement. So in fact, I'm going to know before I start that if I see a less than, or if I see a less than or equal to, I will know that this is going to be an and compound inequality. Okay? So maybe somewhere off to the side, we ought to state that. All right? If I have a less than or a less than or equal to. Okay? That will be an and compound inequality. Now, last week when we started this, I told you that if you couldn't remember which one was less than, which one was greater than, that you should use your what? Your left hand. So I think we're going to still use that same idea, because these two symbols right here will be found by using your left hand. And inside, what? Oh, geez. What is wrong with me? I can't. Listen, I never could spell. That's always been a weakness. I never been able to spell. That's why I write really fast if I'm not sure. Then it just looks like a whole bunch of letters together, and you figure out. Yeah, I've always so no line to you there. All right, but if you can remember that your left hand is a less than, then you can hear the word and inside of there. Maybe that'll help you remember that that's an and statement. What's that? I'm Dr. Seuss. I thought you were saying I was off my rocker. Thanks. Okay. All right. Call me crazy. All right. I'll hear you on that. All right. So when I see this symbol right off the bat, I already know. That is guaranteed to be an and statement. Now, what if it's guaranteed to be an and statement, but it doesn't look like one? In fact, they go this way instead of coming together. What does that mean? It means it looks like an or, but it's not. It was an and. So what does that mean? It's a what? It's a no solution. Because I'm looking for an area that they share in common, and what happened? I don't have one. They don't share anything in common. So that's a no solution. All right. Try this one. Should be very similar to what we just did. Then we're going to look at one weird case, and then we're going to switch and go the other direction. Okay? So right off the bat, it's a less than, which means what? It's an and statement. So you ought to know that right now. Less than, it's an and. So split your paper. What are your two inequalities? One should be super simple. It's literally in front of you. And the other one, you just got to do a little bit of a flip. What's up, Jack? Okay. So let's go ahead and write that first one. Thank you so much. All right. So in this first one, we should be saying that x plus 6 is less than 8. You said that result was what, Jack? Okay. So if I minus the 6 from both of these, I get x is less than 2. So realize that first one looks just like the problem, minus the absolute values. I dropped those because I'm going to write both scenarios. What's case number 2 look like, Tyler? Do you know? Could be. I don't know that yet, to be honest with you. I'm more interested in what is the original statement going to look like. Beautiful. All right, so there's the original statement. Now I want to solve that. You better calculator your answer there for a second. Olivia? Negative 14. All right, so we minus the 6. We get x is greater than negative 14. This should be an and statement, meaning my two results should come together. Do they? They don't? Gotta be careful with this one. Are they? They are? X is less than 2 goes which way? Left or right? Left. Hey, join the club. X is less than 2. It's going that way. Going to the left. Over here, this one's kind of sandwiched in the way. X is greater than negative 14. So we're down here at negative 14, and we're coming to the right. And I'm going to connect those two together for the reason that I'm talking about an and statement, and I'm requiring both of them to be true. So my answer to this problem can be found anywhere between those two endpoints. Can it include those two endpoints? And the answer is no, because these two circles are not filled in. Yes, sir. Yep. So we're going to look at that right now. Okay, my apologies. So in a no solution, here's what's got to take place. We're supposed to see an and, but we don't. We're supposed to see two things come together, and we don't see that happen. Okay, that's what a no solution would look like. So can you visualize how that's going to be possible? It's got to include a less than or a less than or equal to, but somehow the results go away from each other. You think you know what it is? What? What's a negative? what what it's the inequality is essentially set, I don't want to say equal to, but what it's being compared to. So if we take a look, we'll skip this one and yep, we're going to go right here. Like that. How is this going to be a no solution? So I'd almost, if I'm going to put this in my notes, and I think you probably should, I'd almost like star that to say like, hey, listen, there's something in this one that ain't right, isn't right. I'd be at least grammatically correct. Sorry. Watch it. That symbol says and. He said I can't read, write, or speak. I might as well just go home. That's what you're telling me. All right, thanks. Okay. Okay. We're requiring the result that comes out of the absolute value here to be what? Anything that comes out of an absolute value must be anything that comes out of an absolute value. It's got to be positive, right? But the inequality says that my result must be less than -2. Well, how can something that's guaranteed to be positive be less than -2? It can't, which would be enough right there to tell me that this problem has no solution. Okay. Now, most of us, unfortunately, aren't in the game of thinking ahead of ourselves, right? We're typically just moving along, trying to complete something, hoping we're doing it right, unfortunately. Okay. Now, if I recognize that this inequality sign says and, I should expect my answers to come together. But you'll notice in a situation like this, if I write this out, case number 1 says p minus 5 is greater than -2. That's option 1. If I write the other side of it, it says that p minus 5 is, why did I really am struggling. I literally can't even write what's on the board. God. Oh, Thanksgiving break. Watch yourselves. Greater than +2. I'll put gravy on everything. Literally everything. Okay. Yeah, even on my ice cream. Okay. Now, if I solve this by adding 5 to both sides, on the left-hand side, I get a statement that says p has to be less than 3, which is fine. I mean, that's no big deal, right? P is less than 3. The problem comes in when I see what it's going to be compared to. Because on the right-hand side, when I add 5, it says p is greater than 7, which again, on its own, isn't a problem. The problem is I'm saying that these two things are supposed to be an and statement because of the less than, but they're not going to graph that way. Less than 3, goes that way. What in the heck? And greater than 7 goes that way. I don't think I've made that many mistakes in one period in quite some time. Like, I am all over it today. All right? Listen, it was a 3 because I said 3 as I was writing it, and all of a sudden my 8 just morphed into a 3. Then I just tried to quickly put it together. All right? Yeah. Go ahead and make sure you like, subscribe, and don't leave a comment at the bottom of this one, okay? So it looks like an or, because it is an or. Because you can be less than 3 or you can be greater than 7, but you cannot be both of those things.
But then it's a lesson, so how is that means it?
Which means it's not possible to do this. So graphically, it's because we're supposed to see an and, but we don't. Okay. Or originally, algebraically, in the inequality, if we would have recognized what we saw in the first place, we could also say that there's no solution. But when it does what it's not supposed to do, there's one of two things going on. Either nothing works, or the other option is everything works. Okay. So, not 98% of the time, 99% of the time, it's going to do this. It's going to look like what it's supposed to. It's going to say an and, it's going to be an and. It's going to say an or, it's going to be an or. But if it's not, it's because something strange is going on. Okay? I told you we were going to look at 6 questions. All right? Here's number 4.
I think we should only look at 4.
That's okay. We can stop there, then you just don't see the other half, and then you can complain tomorrow when you don't know what you're doing. No worries. Maybe. Everybody hates words, I know. Okay? If the thermostat in your house will keep the temperature within 3 degrees of whatever you set it at, and it's set at 72, what is the range of temperatures for your house? Fine. Macy's house. As low as 69 and as high as 75. Now, let me ask you, if I thought about that graphically, is that an and statement or is that an or statement? It's an and statement? Okay. Because it could be 69, it could be 70, it could be 71, 72, 73, 74, 75. All those values in the middle. If it has to be an and statement, then you should be able to tell me the inequality that would go right there. You only have 2 choices. It's either a less than or a less than or equal to. Which one is it here? What do you think? Is the temperature allowed to be 69 and 75 or 75? You know what I mean? So then what should we include? Less than or equal to, right? We are allowed to have that equal to. So in this situation, we'll go ahead and put in a less than or equal to. Okay. What's that? Picked what numbers up? Oh, the range of temperatures? Okay. So because it says right here that your thermostat will keep it within 3 degrees of whatever you set it at, so it could get all the way up to 75, right? Or on the other side of things, it could drop 3 degrees. So it could drop all the way down to 69. Okay. So because we were saying essentially this, that it was like going to be from 69 all the way up to 75, we said, well, that's got to be an and statement because it includes both of those values and anything in between. So that's where we came up with that. Now, what's the rest of this look like? I mean, there's only 2 numbers in this problem, a 3 and a 72. So it's got to be those 2 numbers in your inequality. What do you think? Are you stretching? Yeah.
I think 72.
Uh-huh.
Go on the outside of
Okay. All right. So out here.
It's wrong.
Oh. Then why did you say that?
I just
Oh. Okay. What do you think? You agree with her or disagree? I mean, whatever. Oh.
I put it inside.
Yeah.
Could it be like x minus 3?
Okay. So
It
now
looks
do
fine.
now do remember that if this is right, I have to write 2 statements down here, right? One of them equal to exactly what it says, and then one of them equal to the flipped version of that.
No, that's right.
Thanks for yelling. Why is that right?
Because when you solve it, you can solve it like that.
Uh-huh. Yeah.
Case 2, you just have to flip the sign and make it greater than or equal to, and then it would be negative.
Okay. There should be your problem when you heard what you said in the second one. Negative 72. The first one's gonna be fine. No problem, right? I'm gonna write that. I'm gonna add 3 to both sides just because say x is less than or equal to 75. Exactly what I want. But the problem is over here. If I wrote x minus 3 is greater than or equal to negative 72 and I added 3 to that, the temperature in the house is now negative 69 degrees. That's just a tad chilly. Just a tad chilly. So unfortunately,
Would it be x minus 72?
I've got a flip flop. Very good. Good. So these 2 values have to change. What mess up was that? I did. I was trying to just grab it and switch them. Quit calling me out, man. Hey. All right. So in this situation here, now you would produce the 2 results you were looking for. All right. On the left-hand side, x minus 72 is less than or equal to 3. When you add the 72, you get that 75 you were looking for. And I don't know why you're yelling at me. Jeez. Okay. There, if you add 72, you get greater than or equal to negative, or excuse me, to positive 69. Why are you going after Tyler? He's not doing anything. You know, like why are you calling people out? I mean, you be careful. We all got skeletons, right? So be careful. I heard some good ones. Okay. Now, on the other side of life, if we don't have less thans or less than or equal tos, we have greater thans or greater than or equal tos. It would stand to reason that if less than or less than or equal tos were ands, then greater than or greater than or equal tos should be ors. And they are, okay? So this statement here is an or. Okay, if you want to, if you came all the way back here, I could write a second statement here that says if I have a greater than or a greater than or equal to, that will be a or compound inequality. Okay, that'll be a compound inequality with an or statement. Now, I don't have a fancy like your left hand has the word and inside of it. I've heard two different things. You can take them or leave them. You can say no, thanks. All right. I've heard these two things. Number one, instead of saying greater, you can think about it like great or, like it's got a yeah. I gave you full disclosure at the beginning. I said to you 2 seconds ago, if you didn't like it, you didn't have to take it. I said that. Yeah. You may okay. All right. Totally agree. All right. The other one I've heard is people say this. Instead of greater, they say gator. I don't know if that's from the whole like it eats the bigger number thing. I don't know. But again, it has the OR in it. And so the G for greater maybe and the OR, I don't know. All right. I here's what I do. If it's not a left hand, then it's an or. That's kind of how I think about it. You don't really need something for both, do you? If you have something for one, you got enough for both. So that's something to think about. Now, we're just going to look at this one here. So we see one that works, and we're going to look at one that doesn't, and we're done. Okay. In this situation, however, though, the idea doesn't change. So I should write what over here on the left-hand side? Andrew, can you tell me what would be on the left-hand side over there? What am I going to write for the initial statement? Okay. So 3y minus 3, use that symbol, greater than 9. What's the other side going to say? Okay, good. So 3y minus 3, and then remember, we've got to flip that sign. So instead of being a greater, it's going to be a less than, and then negative 9. So here you can almost kind of see that if you want to be greater than a positive and less than a negative, can you visually think about what your values are going to do? You want to be greater than a positive and you want to be less than a negative. They're going to do what? They're going to go away from each other. All right. They're going to move away, which is creating this or statement that we talked about in the first place. Okay. So if you want, you can solve those two. Shouldn't take you long. Should take you 30 seconds. Well, if you add 3, you get 3y is greater than 12. And now if you divide by 3, one statement is y is greater than 4. And again, because your variable is the part that repeated, you're going to essentially do the same things over here, obviously to a different result because you're not setting it to 9. You're now dealing with -9. Okay, so you get 3y less than -6. If you divide this by 3 and you divide that by 3, you get y is less than -2. To be greater than 4 goes which way? To the right. To be less than -2 goes to the left. So we do get that split here of an or. Okay, 0, 2, 4, we're to the right of 4, or we are to the left of -2. Because it's an or, you're only requiring how many things to be true? Just one. So it doesn't matter if you pick anything bigger than 4, or if you pick anything less than -2, that's an answer. Okay, but it's nice to know before you ever start what it is you're supposed to see. But she yells at me when I didn't yell at her when she told me the answer was going to be less than 2. In fact, that it was a -2. I didn't say anything to her. But when I make a mistake, she's all over me.
We had to write the arrows down.
Okay.
Make sure we have our notes.
There you go. All right. So the only other thing, I know this is like a beginning to end. I'm sorry, this one's long. This one is long. All right. The only other possibility would be if it's supposed to be an or, but it doesn't do that. If it's supposed to go away, but it comes together, then it's an all solution. All right. And here's an example of what that would look like. We'll skip that one and take a look at this one. Why is that an all solution? You can almost see it from the beginning. Kyler, do you recognize it? True. Nah, listen, that's a right-handed symbol there, so that's a greater than. Whoa, what?
Because the 5 is connected to.
Well, true.
I just because in these ones.
Yeah.
No, never mind.
Caitlin? Okay, what do you think? And then we're gonna. What's greater than the negative? What happens to anything inside an absolute value? It's positive. So a positive has to be greater than or equal to a -2. No matter what you pick here, will be forced to be bigger than 0. Or anything that comes out of an absolute value has to be what? So whatever comes out of here has to be positive. And a positive will always be bigger than a -2. No? All right. Okay.
Oh, because it's a negative.
Yeah. So this is guaranteed to be an all solution, but that symbol says or, right? But if I write it, 5x minus 1 is greater than or equal to -2. And on the other side, 5x minus 1 is less than or equal to +2. When you solve those, you're going to find out that their symbols don't go away from each other. In fact, they actually come towards each other. And the reason that they come towards each other, because you want to be greater than a negative, which way is that going to work? To the right. Things that are greater than a negative are going to move to the right. But over here, things that are less than a positive are going to move to the left. And because it's an or, we only require how many of them to be true? 1. And if they work towards each other and go past each other, right? So over here, if you solve this one, you get 5x is greater than or equal to -1, and you divide by 5, and you get x is greater than or equal to -1/5. And over here, if you add the 1, you get 5x is less than or equal to 3, and you divide by 3, and you get x is less than or equal to 3/5. I screwed up again for the 44th time. That's a 5. Things that are greater than or equal to -1/5. If we said -1/5 there, they go that way. And then if this is 1/5 and 2/5 and 3/5, this one is here going that way. But I don't connect them because the word or doesn't require both of them to be true. The word or gives you choice. right? If I said to you tonight, you can do your homework or not, then you choose.
Or not.
You probably choose not, right? You get one, right? You only have to do one of those things. And so you're like, I'll choose the no. Thank you very much.
Can you give us that option?
Sure, you always have that option. All right. But in this situation, because you only require one of them to be true, eventually you cover everything on the whole map. And so that's why this or comes together and ultimately leads you to that statement. Okay. Now, I haven't given you anything out of your book to look at in quite some time. This is like 6 questions, I think. So I'm not asking you to try a ton, but I am asking you to practice it. The setup is probably the most important piece. Solving it will be easy. A lot of them are 1 step, 2 steps at the most. Okay. But the setup is what's gonna be beneficial to you here.